So hurricane formation, the right environment. Hurricanes form over tropical water where the winds are light, the humidity is high in a deep layer extending up through the troposphere, and the surface water temperature is warm, typically 26.5 degree or more than that, over a vast area. These conditions usually prevails over the tropical and subtropical North Atlantic and Northeast Pacific Ocean during the summer and early fall. These oceans usually reach their peak sea surface temperature in August or September because the lag in seasonal temperature. So the official hurricane season extends from May 15 to November 30 in the Northeast Pacific from the June 1 to November 30 in the North Atlantic, although few tropical storm hurricanes have formed outside of these dates. For a mass of unorganized thunderstorm to develop into a hurricane, the surface wind must converge. In the northern hemisphere, converging air spins counterclockwise about an area of surface low pressure. Because these types of rotation will not develop on the equator where the Coriolis force is zero. Hurricanes usually forms at some distance from the equator between about 5° to 20° latitude in both hemispheres. In fact, about two-thirds of the all tropical cyclone form between 10 to 20° latitude. Hurricanes do not form spontaneously. They require a trigger to start the air converging. The surface wind converges along the intertropical convergence zone, we know ITCZ. Occasionally, when a wave forms along organized and the system grows into a hurricane. Weak convergence also occur on the eastern side of the tropical wave, where hurricane sometimes forms. In fact, many, if not most Atlantic hurricane can be traced to tropical wave that form over Africa. So, the convergence of surface wind may also occur along a pre-existing atmospheric disturbance such as a front that has moved into the tropics from middle latitude. Even when all of the surface condition appears nearly perfect from the formation of a hurricane, for example, warm water, humid air, converging wind, and necessary triggers, the storm may not develop if the weather conditions aloft are not just right. For instance, in the region of the trade wind and especially near the latitude 20°, the air is often sinking in association with the subtropical high pressure area. The sinking air warms and creates an inversion above the surface known as trade wind inversion. When the inversion is strong, it can inhibit the formation of intense thunderstorms and hurricanes. In addition to that, hurricanes do not form where the upper level winds are strong. The resulting strong vertical wind shear tend to disrupt the organized pattern of convection and disperse the heat and moisture, which are necessary for the growth of a storm. Another unfavorable factor for hurricane formation is Saharan air layer, we call it SAL, a mass of dry air and blowing dust about 1.5 to 6 km above the ground level that can cover an area as large as contiguous United States. The pulses of this SAL Saharan air layer move west from the Sahara Desert every few days. The dry air and strong wind associated with the SAL can weaken hurricane and inhibit tropical cyclone from developing. The warmer than the normal water over the eastern tropical Pacific during the El Nino condition favors the development of greater number of hurricanes than average over the northeast Pacific. On the other hand, the same El Nino condition helps to generate strong vertical wind shear over the tropical North Atlantic, so fewer hurricanes than the average tend to form there. When the water over the eastern tropical Pacific turn cooler than the normal La Nina condition, vertical wind shear tends to be weakened over the tropical North Atlantic, producing more favorable condition for Atlantic hurricane development.